All right, so this panel, and thank you for joining us this afternoon. We know that you guys just had lunch and are probably going into a food coma, so you're probably ready to fall asleep. So I ask that you try to pay attention, and we've got some very smart people in here, and so I want to hear what they have to say. This panel is called Do It Like a Hyperscaler, Engineering Containers for Security and Hostile Multi-Tenancy. So I guess I want to get in with the introductions in a minute. So my name is Jason Perlow. I'm Senior Technology Editor for ZDNet. I've been blogging there for about 10 years. I also, in order to pay my wife's credit card bills, I am a solutions architect at Dimension Data's data center and cloud practice, where I design solutions for large enterprises. My focus is more or less on business continuity and disaster recovery, and also systems migrations. But we've been increasingly doing more and more things with containers, and specifically container security and orchestration. So this is a very front of mind topic that I'm particularly interested in. So I'm interested in hearing what these folks have to say, because they're a lot smarter than I am. So we have our panelists. Matthew, would you like to go first?
Sure. I'm Matthew Barker, solution architect for Twistlock. I've been in the app security space now for about 8 years, and I've been focused on container and cloud security with Twistlock for the last year or two. It's great to be here today.
My name is Rob Hirschfeld. I am CEO and co-founder of a company called RackN that specializes in data center automation, so base, boot, physical infrastructure type of stuff. I've been involved in cloud and container work for quite some time. Early days with Docker, we actually built our application as a containerized application early in the Kubernetes group, and I've been doing OpenStack and related infrastructure work there for quite some time, since the beginning.
I'm Robert Starmer, founder and CTO for Kumulus Technologies. We're a systems consultancy, and we help people get into the cloud, figure out what to do with the cloud, basically make cloud easier to use. And as a part of that, of course, the security of those cloud environments becomes a very important aspect of how those resources fit together. So that's why we wanted to talk about that class of security, specifically as it applies to the DevOps space and now containerization, right?
Great. So let's get to the meat of the stuff. We had a prep call about a week ago where we sort of discussed what we were going to talk about today, but I just wanted to frame the discussion just to remind everybody kind of like why we're here today. So if you're a service provider, large enterprise with a private cloud, that you don't want one customer's or tenant's code or applications to interfere with your service or to gain access to the data of other customers, but you need a container, right, that's more agile than a virtual machine and that takes advantage of the tooling and compatibility of the overall container ecosystem, right? We're talking about the fundamental design decisions for building a public cloud, a large public cloud, or running a large public cloud service. Large service providers or hyperscalers, right, such as Azure and Amazon Web Services, they run in what's referred to as hostile multi-tenancy, since they have to assume that they have customers that are deliberately looking to subvert their isolation by attacking other tenants or the service themselves. It's also possible that you might have employees internally that run the public cloud that might want to subvert the service, potentially. Let's take a look at what happened with Edward Snowden. They had a completely secure environment in the NSA, but you had an internal person with God mode administrative capabilities that was able to literally subvert the service. So we believe that in discussing containers in public and private clouds at the hyperscale level is probably best practice even for small and medium-sized enterprises that are still they're even working just in the application space itself, even if they're not actually running the infrastructure. We think there are three pillars. One is security, right? The other is agility and orchestration, and the third is portability. All these tiers we think are critical to architecting a successful public cloud service or a container-based systems architecture. I'll start with one of the topics. Robert Starmer actually suggested this one. So does it make sense to do containers on virtual machines or on the metal? Obviously, there are benefits to doing things one way or the other.
Well, so when we think about this relative to, again, those sort of three key pillars that we want to talk about: agility, security, and portability. The portability piece comes from using containers, right? That's your nice unit of aggregation. We've packaged up our application as a container or a set of containers. The security aspect, then, one of the questions that comes up, and one of the reasons that I think this question of VM or not to VM your containers comes up, is there's a question of what is the security, especially in a multi-tenant environment, in one of these hyperscale environments. What is that security between the container and its neighboring containers, the other containers that share a same Linux kernel, underlying Linux kernel together? Now, a lot of work has been done, OCI and the containerization community at large has done a lot of work to make sure that very few openings still exist for a container to expose itself or to basically get access to the kernel beyond what it's supposed to have access to. So there's a lot of work that's been done there. But there still are some other advantages to saying, well, I might still want to segregate that container. The container is my packaging unit and my runtime unit, but I still want to wrap that in a virtual machine to get virtual machine segregation from everybody else. But it's not just about security. It's also about the fact that that container is a process, right? It's very possible for one process with poorly defined infrastructure to potentially take over the entire machine. So while it's not a security impact, it might be a denial of service impact that you're potentially protecting yourself from by virtualizing the underlying infrastructure that the container lives in, right? So it's multiple different avenues. I'm a huge proponent of saying that there's value still in, especially in a multi-tenant environment, in virtualizing the infrastructure that your container application runs on top of. Now, that doesn't mean it's one container per VM. It might be multiple containers as a part of an application. Following the Kubernetes pod model, you'd have the entire pod at least.
A tier per VM.
Yeah, a tier per VM sort of a thing. And it might be that a tenant sort of builds out their environment as virtual machines that then gets basically access through a restricted Kubernetes access environment, for example, into those particular VMs. Right, so you can do sort of node mapping on a tenant by tenant basis. So,
as someone who is an enterprise that's really looking at running just their application environment in the hyperscale cloud rather than being a hyperscaler and having to design that infrastructure, what is the implicit trust level of the actual hypervisor infrastructure at a large public cloud provider like an Azure or an AWS? Especially now that they're starting to bring in things like kernel-based security and hardware enforced isolation and things like that.
I still think that, again, the security aspect, I believe that the community at large has been driving very hard to make sure that that has been handled effectively, right? That it's very, very difficult to break out of your container. But I still think that there are other advantages. Like I said, probably the bigger advantage is in an environment where, whether you have a security concern or not, you're still looking at all of the other aspects of security, right? One view is, oh, security is you broke into something. But denial of service is another security attack in a sense, right? I'm denying you access to the resources that you expect to have that might also cause problems. So again, being able to segregate, virtual machines are a very useful tool in doing that. That doesn't mean that you don't find value in having entire bare metal machines, right? And if you can treat your bare metal like you do the virtual machine, which is effectively what Rob and company do, that gives you another aspect of that same kind of segregation, right? Separating the resources.
I mean, but let's look at what because I think there's nuances here in what hyperscale does and what you get in public cloud, where they have big infrastructure as a service offerings based on virtual machines. And what they're actually doing is they're running, say, a Kubernetes cluster for their customers in a Kubernetes cluster, typically, so they can spin that up and down really quickly, and then they add resources based on their infrastructure as a service offering into that cluster. To me, that's a stopgap, right? What they're doing right now is they're saying, look, we can spin you up a Kubernetes cluster, you can use it raw, or you're going to pay for the resources. The granularity of that type of environment is relatively big. It's what the customers are already used to paying for because it's the IaaS infrastructure. They don't want to have the fight over whether or not the containers are secure, so they give people dedicated worker nodes in those clusters. And this pattern, we've seen it in Amazon, we've seen it in Azure, we've seen it in IBM. GKE, they're containers and VMs inside of containers at this point. So it's a little bit redundant, but that's how they're packaging all this stuff together. When we look at what people are doing on their own premises infrastructure, at that point, the added burden of virtual machines is probably added burden.
Because you trust your own infrastructure for the most part.
Well, it's not a matter of trusting your infrastructure. It's a matter, I mean, from a security perspective, it's a matter of trusting the way the containers themselves that are being deployed and how they're being used and managed. And you could add virtual machines as a lot of people, that's what people are doing today. It's crazy, if we talk current state, it's VMs.
I'm a bit on Robert's side here. I'm a firm believer in security in layers and not trusting one place for your security, because quite frankly, there are always holes in every single network, container security you can set up. Known vulnerabilities get reported on containers, components in an application. Some of them have hundreds of vulnerabilities. So there's always going to be some kind of attack surface. So having the extra layer of the VM the container's running in is going to limit the resources that container can get to if they break out of the container. Mm-hmm. And you have the added security of the actual VM as well. Yeah. Security in layers. Yeah,
I think that that's a fantasy. I think that the idea that a virtual machine is more secure than a host, if you're breaking out of a VM to get into if you're breaking out of a container to get to the VM, it's a host. It's still a host. All you're talking, I mean, you're limiting your impact surface potentially.
Yes.
But you have just as big a mess to cover. You have just as big of a risk of people penetrating your infrastructure from that host that they've compromised.
Well, I'll give you a good example. There was an attack recently where someone broke into a container, and then they found the container had a socket connection to the Docker socket on the host, and they were basically able to create their own containers from their own images and have a huge attack, where they would be limited to a VM with the VM underneath it. You're limiting the attack surface. You're going to assume that they're going to get through at some point.
Well, I think broken into a host, you've broken into the host, right? At that point, you're back to, is your host security good or bad? This to me is, I agree with what you're saying, and people like this premise of saying, if I put it in a VM, then it's a smaller unit, but you're just as compromised.
Yeah, I think that there is, I think, a security value, or at least if nothing else, a feel-good value. If we really want to get to that point, right? I think there is a value, but I think there are secondary values as well to the virtual machine underlay model, and that is a higher order resource restriction. I know that if somebody has decided that Kubernetes and containers are the answer for all their applications, and they're able to go that way, then there is probably less value in an enterprise to also virtualizing the container world. In a service provider, I still think that there's value, and in an enterprise that hasn't yet decided or hasn't yet been able to move everything into a containerized approach yet, then suddenly you need that virtual machine infrastructure, automating the scalability by saying, well, look, I'll give you another share of my overall resources, which might be a complete bare metal machine, right? We can manage bare metal or virtual machines in that level. Sort of managing that resource that I add or remove from a container environment, I think the virtual machine space gives you that flexibility too. So there's a security aspect and a systems management aspect that I think provides additional value.
There's also a cost component that is a negative for this, right? This to me is where we really have to figure out, and we're in transition right now with what's going on. If somebody shows up with containers and I don't have a Twistlock or something to protect myself from what's in those containers, then of course I'm going to want to put wrappers around that to make sure that the next customer down the line isn't vulnerable if this customer loses containment. And that makes perfect sense to me, and VMs are a good way to do that rather than just giving people full machines. Because you've made the decision, I am not, and this to me is, it's not a VM versus metal decision, it's a containment decision. Do I want to, where's the barrier that I want to have containment for customers? And it's going to be a host boundary. And I don't care if that's a metal host or a VM host. You said, I am not commingling customers on hosts. And VMs are now a good way to make hosts smaller.
Mm-hmm. And you don't have to do it one way or the other. I mean, just the same way with storage tiers, you have gold, silver, and bronze. I think that you're going to have service levels for containers whether you're using a VM or one type of container or another, you're going to have service levels depending on the density of the host and what the hyperscaler wants to offer in terms of price points.
But, and this is where, to me, you start losing ground on the VM argument with price points, because once you've decided you're packaging in VMs, now you've got to spin up a VM to add capacity, you've got to spin down VMs when you lose capacity, and you're going to pass that on to the customers. As we get more and more container workloads and we have better ways to introspect those containers to make sure they're not bad actors, then you want the granularity to be, am I running a container or not? You're closer to functioning.
Yeah, and I think the key point there is, as we get better functionality to introspect, to understand what those containers are doing from outside the container, right? I mean, usually the provider of the container infrastructure has a lot of visibility into what's going on, but they don't necessarily have all the tools that they need to be able to see that, you know, you have a good or bad actor being deployed. I mean, there was I think it was actually in the session that we had yesterday, the panel session yesterday, there was a point that one of the issues with containers and container registries right now is the fact that people are not updating the container as operating system worldview, which really is probably the biggest problem there, but that container as operating system world, which is effectively what people that were in virtual machines migrated into containers, and they said, well, I'll just keep all my operating stuff with me because I feel more comfortable working with it that way, rather than building secure containers where it's, here's my Go binary. I wanted to put it in a container to make it easier to move around because I have tools for moving and manipulating that, but I also only have the Go binary in that container. That's all I needed. Right? There's still that disconnect there, and
so yeah, now we're in sort of the portability aspect of the discussion, and I think it's going to become more of an issue as we move into the non-x86 space, because you can see the large hyperscalers are now moving into ARM, and they start deploying tens of thousands of ARM SoCs and clusters, where you're really going to be consuming finished services running in containers that the hyperscalers develop. Right, and you're just executing your code on those finished services. Portability of that code, right, and portability of containers that you might want to move back and forth between services or providers is going to be more critical.
Yeah, well, and the portability argument, you know, this whole, we move the entire operating system rather than a binary, maybe even a binary that I could emulate if I wanted to run an x86 binary on ARM. I'm not sure that's the right approach. But you know, if you wanted to, if you limit what is in that container, you have more control over how you run it, where you might run it. But I think the bigger thing from the security perspective is containers make things easier to move. They just provide a simpler model for migrating resources around, because they're a better bundle, right? They're the complete bundle, rather than, oh, I've got to pull additional pieces in to make this one application element work, which is like the classic VM approach to deploying resources these days, right? So we see that shift. But the security aspect is still there, because a lot of people are saying, well, my binary needs to run on top of something, and I'm comfortable saying I'll start with an Ubuntu or Red Hat or whatever base OS, even though I'm not going to use any of the features that are there. Right? I just want to run my application, but I still brought this entire baggage with me in the container space. Right? So portable, yes, but that doesn't mean that you've improved security in doing it that way.
Yeah, that's actually a favorite topic of mine. The idea when you pick that base OS for your containers, what's become really popular these days are things like Core OS and Alpine. And a lot of the advantages of that is a very small footprint, very small images, but there's a much bigger advantage, and that is on the security side. Because they only contain, you basically get an Alpine image and you just add the utilities you need to service the app that's in the container, then your attack surface gets really shrunken. I scan images like probably 30 or 40 a week during my work as a solution architect, and I look at Ubuntu, something like 14.04, 16.04, there's like 100 vulnerabilities. And then I bring in Alpine, and there's either 0 or 1, or something like Core OS. So having those lightweight, very minimal OSs in the containers, from a security standpoint, is the best practice.
Yeah.
I would make the same statement about it in the host, right? With the way we're approaching containers, the hosts can also be very lightweight. And so we're moving into a state where, you know, you're also minimizing your attack surface if somebody does manage to escape from the containers.
Right, well, this is, I think, you know, to your point, the Core OS, what's the Red Hat one? Anyway, basically container atomic, right? So basically container OS, right? An OS that has enough resources to launch a CNI container effectively and sort of manage things at that level. Yes, then the container itself should be lightweight. And I think we should go even one step further. It shouldn't be any OS. The container application has OS resources. I mean, that's what Atomic and Core OS and Rancher OS and all these others still provide, that full suite of, time interfaces and everything else that you might need, network and storage resources, are all sort of in that container operating system, right? Then your container itself can really just be the binary, and maybe it needs some additional libraries because it's still an older school application where you have to pull in a different version of like a SSL library, which is dangerous because now you've created a potential data point that well, unless I keep that SSL library up to date, right?
So are these best practices good necessarily for legacy applications, or were we really talking about net new, designing new architectures and new apps? Because I find that legacy tends to bring so much cruft with it, you're kind of forced into it in the mini.
Well, so I think one of the problems is that legacy applications often also have legacy requirements in terms of libraries, in terms of some of the resources they expect to see, because the application itself has not been updated. And that's basically like saying, well, I'm going to bring my my old locks that you can pick with a steel axe effectively. I'm going to bring those along with me, and they're going to lock my luggage because they worked in the past. Right? But I'm going to bring those and I'm going to put them in a nice, newer, bigger container and a bigger suitcase, and I'm going to put a TSA lock on it, which is really easy to pick too, right? But I think I've secured everything, even though all the layers have these massive vulnerabilities in them, right? Being able to take that application and say, well, look, if we're going to modernize it, if we're going to containerize it, can we rip out all the libraries and create that segregation? Is that even possible, right? Does that break the application because nobody knows how to update the code or whatever it is that causes that interaction? Right?
And
So, yeah, go ahead.
I was just say what I'm seeing with the companies I talk to is that the majority that are looking at going to the cloud and containers are going to modernize their legacy apps. There is a lot of technical debt in those apps, but there's some of that technical debt is just security risk, and so they really can't afford to leave the legacy apps out there and be like the next Equifax.
But the danger.
This is where we really start talking about continuous integration, continuous deployment. And it's very hard, it's not that hard, but we shouldn't talk about containers without it in context of a continuous delivery process.
Yeah.
If you're building containers as one-off artifacts and deploying them like you would do a legacy application, this is my golden container, I can't
Exactly.
deploy it just like this.
Yes.
And the first step in the Docker run is apt-get update, you're in a very bad place.
Yeah.
And I've seen people it's horrible. The thing that comes with this, and to me the real security posture here is not about hardening the hosts and VMs. I mean, I think that you have to have that conversation, and we did. The real security posture here is about a continuous integration process where we're saying, look, we are always pulling in the patches, we're always pulling in. We never take stale containers and deploy them. They're constantly being updated and adjusting to whatever patches, whatever releases, right? You get Equifax where they didn't have the ability to patch even though they should have and they could have. That inability is the bigger security problem.
Yeah.
Well, we haven't always agreed with you during this session, but I think both of us are in 100% agreement here.
Yeah.
The idea of a continuous delivery with containers, there are so many advantages. Having short-lived containers, frequent deployments, frequent updates. There are huge operational advantages that have been proven out to show DevOps is kind of taking over the software process world. But there's huge security advantages too.
I would say you could take the word containers out, and that statement should apply to virtual machines. It should apply to data center infrastructure.
Yeah.
DevOps has transitioned from being about tools like Chef Puppet, right, where about configuration, being about pipeline. And that's such a better conversation.
Yeah.
So how does, we're kind of like sort of getting into the agility orchestration aspect of the three different pillars we were discussing. How does, how do these different container architectures, right, and whether it's VMs or it's one type of container or another, and different operating systems have different types of containers, whether it's Unix or it's different types of Linuxes and different flavors. And Windows has Windows containers also, plus Hyper-V containers. And
Solaris has zones.
yeah,
Don't
Solaris
forget Solaris.
zones. You got AIX, LPARs and WPARs and all those good things. How does all these things, sort of affect agility and orchestration issues, right? Because you're talking about continuous development, right? I mean, that's constantly being agile, in my opinion, essentially.
Yeah, I think that the push to being agile sort of comes with it comes from that portability aspect. The agility, then, as Rob just said, DevOps used to be about just that automation and configuration management of these crazy sets of applications that people were putting together and trying to then run on a single virtual machine, creating all kinds of interesting interactions because, oh, well, this part of my application required this library and that part required this other library and everything blows up, right? Of course, your DevOps pipeline, if you actually have implemented one, which a lot of people still haven't or haven't been able to, would have caught that because it would have tried to run that final application. The nice thing about containers is that in that automation cycle, yes, you may still be running apt-get inside of a container deployment to build something. I mean, you might need some additional resources, like where do you get those packaged libraries? Right? Did you build them yourself, or are you getting them from some upstream source? Those are all fine approaches so long as you have the agility through that automation, automation pillar effectively, to say, look, when we do find a bug, we can update our code, test our code, and push our code into production. And containers provide a really nice packaging mechanism for that. The container operating environments, Kubernetes really being the one that I think everybody talks about anymore, is a great way of then running those containers, and that improves your end-to-end security pipeline, because you can say, if I find a vulnerability, if there is a CVE that comes out, I can now address that.
Yeah, because that root image is going to be deployed to every single container in your environment if you want it to be. Whereas if you work in a VM-centric environment, right, patch management is always going to be a bear because every single image then, unless you're using storage dedupe and other types of technologies, for the most part, each of those VMs has to pull down those patches individually and implement them by a policy, which is one thing I wanted to talk about is, security implemented by policy and automation, how do we achieve those levels of automation for things like patch management and things like that?
Yes, so I think there's a couple things that are important to be able to reach that goal. One is what I see a lot is companies doing like their very best to check and make sure before they deploy that everything's secure. And then they deploy and sometimes forget.
I think that's the danger. It's like, yeah. I deployed it. It's running.
It's all secure. There's no vulnerability. We had
good.
0 vulnerabilities, which is no small task today. Right. So a couple things that are needed, obviously, is continuous monitoring of everything in all your containers. And automation's a key here. You can't have people going in and going on Google or going to National Vulnerability Database and doing checks. You need tools to automatically alert you when new vulnerabilities come up in any of your deployed containers. But you also need to do a shift left policy here where when you're developing your next release of your application, that you catch the components and binaries in your container as early as possible and remediate those. So the best place is at the developer desktop, at your build, at your CI. So that shift left is really critical here. So the next release goes out clean without a lot of rework.
People start talking about DevSecOps, where the operations isn't so much focused on turning a service on, but it's more about operating at the security layer, saying, hey, look, the security is the thing that I really need to pay attention to. Right, and start operating my security environment, which I think is effectively what you're talking about, right? Shift left, move the security concern, not to something that gets tested at the end as a part of the final QA stage, but gets tested very early on. Do I have any vulnerabilities? These are the versions that I'm running against. Where can I match those things up? And that's probably some of the gaps that, Rob, you were saying. There aren't necessarily yet good tools for introspecting a running container, or at least the container image, to say, well, this is what's in here.
So I think we are very early in the journey of tools and things like that. However, I think it's very important to recognize that because containers are transparent, meaning if you're sitting on the host, you can introspect them. We can add tools at the host level, physical or virtual, I don't care, at the host level that actually analyzes, prevents bad behavior, right, corrects things that are going on, says, oh, somebody opened an SSH port, there's, right, or it's not even that, that's a port. Inside of the running code, you can actually take advantage of container transparency and catch and stop. You cannot do those things with a virtual machine. In a virtual machine, it is by design from the host level opaque.
Yep.
And you're counting on injecting things into the virtual machine or monitoring passive behavior it throws off. And I believe we're moving towards a phase where VMs are going to be considered fundamentally less secure than containers because we can monitor the process flows in a container.
They're definitely less flexible.
Yeah.
Well, but I actually think with active monitoring and whitelisting of processes and things like that, containers should be more secure because we can actually guide them through. If you're looking at a virtual machine and you've deployed it, if Amazon is running a virtual machine, they have very little to do except monitor network traffic to know if that machine has been compromised. But a container, they could actually tell you exactly the moment it's been compromised and when and by what.
So I both
set up
agree,
for
I
you.
both agree
Is
and
that the way out?
disagree with you. So I have to put a little plug in for Twistlock. So what you described as far as monitoring the containers at the host level, everything they're doing and being actually able to actively stop attacks is really one of the pillars of our product. But whether those containers are running on a host or virtual machine, for us is irrelevant because you can run the security tool inside the VM and get the same protection.
So this is why I think VMs are a stopgap measure. If I have that type of introspection and control of the container, then I'm not as worried about making the containment size, which is where we started, smaller, because at that point I'm worried about efficiency, not about containment.
Well, but I think there is still a potential use for VMs in this case. No. And yes, potential
Like
use.
Cisco and eBird
Yeah,
here.
exactly. Well, no, I see that. If we could get to an all-container world, I think we'd all be probably much happier. But there are still people that just have concerns, whether they're real or proven or not. Being able to separate tenancy at a VM level, even if you can then within that VM, as the provider, run tools like the Twistlock tools to understand what those containers are doing and try to make them more secure. Right. There still is that faux physical segregation that I think is useful for some tenants. So we're going to see it.
I agree with you. I don't think that we should run around, pulling virtualization.
Twist your arm a little bit.
I think that and having survived OpenStack, I think there's very good applications for virtualization and segregation and using VMs for things because they're fast and easy and lightweight. All that's very good. I think that we're entering a phase where containers do allow you to say, well, you know what, I'm much more worried about efficiency and simplicity of the infrastructure. And there's a lot of security to me in creating much simpler infrastructure. If you talk to the hyperscalers, if you talk to the hyperscalers and find out what they're doing, they eliminate every layer of unnecessary
and I think
automation complexity.
Right, and so as people get their DevOps and CI pipelines working more cleanly and able to deal with the security aspects and sort of build out their containers on the fly and stop deploying on top of an OS container, right? So that they've restricted what they're even putting into that resource. So you've basically reduced your attack vector, your attack surface just by taking stuff out of a container. Even though the container is hard to get into already, right? But I just don't need extra cruft in there that might suddenly expose a new vulnerability that nobody had found before, right? So the more of that happens, then I think we will get to a point where really what you're looking at inside of the container is specifically that process and any library level vulnerabilities that might exist there, rather than that plus everything else that still has to be sort of managed and manipulated. And of course, if you've gotten to that level of pipeline, then when you do find one of those vulnerabilities, you can swap your application in seconds potentially to fix it, right? So you don't leave that attack vector open very long.
If you have that automation.
If you have that
If you have the CD.
Yeah.
It's really interesting. I would encourage all of you guys to look up good articles on the difference between continuous delivery and continuous deployment. Because being able to put something out within 30 seconds is really continuous deployment.
Yep.
It's where a developer makes a change in the code, fixes like a vulnerable piece of code, commits, and it's deployed within a minute.
And that's
in production.
That philosophy is being embraced not just at the DevOps level, but also at the vendor operating system level. You see what Microsoft announced at Ignite this week. They're going to be doing continuous delivery of Windows Server. almost on like, they're going to have a long-term support level, and they're going to have like a monthly, level like they do with Ubuntu, essentially. So we have a few minutes left, and I want to take one or two questions from the audience in case you guys had any other additional questions. I know this is a huge topic, and we could continue for hours on this, I'm sure, but
yeah.
but they're going to be kicking us out of here pretty soon. Any questions? Comments? Do we want to talk about the new Star Trek show? Do we like the Klingons? Yes?
Well, I think that goes right to the conversation we've been having about, do you need virtualization? Do you need a virtual machine layer between your container environment or not? And I can see some value, especially if you're just trying to transition step one from AWS into OpenStack and you already have an OpenStack environment, then deploying a container environment there that supports the scale that you need, deploying it as VMs, or if you have Ironic stood up, then you can deploy as bare metal. OpenStack is a fine tool for managing that level of infrastructure. I think the longer vision, though, would be for you to look at how you get to continuous deployment effectively into a container-native environment where you don't necessarily need OpenStack in the picture either, right? So you could eventually, over time, move to that. And I think it's just a question of internal infrastructure, internal teams, their capability of using that infrastructure in that way. I'm a huge proponent of OpenStack. I help people build OpenStack systems all the time still, and I see no issue with continuing to do that for the long run, even though Rob may wish that we didn't.
No, I think it's fine.
I'm just kidding. No, but
It's a good thing I sat in between you guys.
If you have a good working OpenStack infrastructure that's already successful, use it. It'd be crazy not to.
Yeah.
If you're going to go 100% containers and run nothing but Kubernetes on your hosts, then you're wasting time, money, and effort maintaining an infrastructure to add virtualization on top of it. Just go containers on metal.
yeah, I mean, especially if, again, if you can run your entire infrastructure as containers, then you don't need OpenStack, right? Kubernetes provides you all of that set of resources that you need to run your application. Perfect. If you need something else that the OpenStack community provides, then you might want to use that still, right? And absolutely you should.
Awesome. Well, guys, thank you for coming today. I think this was a great discussion. I know we could have gone a lot longer. But everybody, thank you for coming, and hope you guys have a great rest of the week here in Austin. Hopefully the weather cooperates. You guys can do some outdoor shopping and entertainment rather than being stuck inside and drinking all day. All right? Thank you.